पूनम, अनुषा हो जाएगा।
अनिल त्यागी सर के बोलने की मैंने भी यही बोला
इसकी आवाज़ क्यों नहीं आ रही?
हटो हटो हटो।
ये तो मैं म्यूट होऊंगा।
जॉइन ऑडियो कहाँ से होता है? यहीं से तो कहीं से होता है।
सही तो है, जॉइंड है वो, वरना ये म्यूट अनम्यूट का आता नहीं ऑप्शन।
तो आवाज़ इसकी हमें नहीं आ रही है, किसी को भी नहीं आ रही है।
आवाज़ किसी को नहीं आ रही है, इसकी जरा चेक करना।
इसी लिंक का पड़ी हुई है, इसी लिंक का है।
तो यार ये ऊपर क्यों नहीं आ रहा है?
ये कौन बुढ़ा बैठा है?
आई हैव नो आइडिया।
हाय हाय।
इधर क्यों नहीं आ रहा है ये?
Now see, is it fine? Is it cool?
It's not audible.
It's not audible. अभी भी it's not audible. अभी कैसे है? Not audible?
Are you unmuted here?
No, I am unmuted. Yeah, I am unmuted. आवाज आ रही है ना? Guys, people in the meeting, if I'm audible, chat पे मैसेज कर दो कि एक बार if I'm audible. Fuck man, कोई किसके पास और ईयरफोन्स है?
Yes, I have mentioned.
दे दो. Yes. Okay, जय भैया. अरे ब्लूटूथ वाले. अच्छा ठीक
वो
है.
हो जाएगा, पहले ये तो चल जाए। लाइव जाने वाले थे ना।
ब्लूटूथ किधर से ऑन करते हैं?
I have no clue.
अच्छा आगे आगे.
इसमें चेक करना, आवाज़ आ रही है इसमें? हमारे को नहीं आ रही ना।
अरे भाई मैम आ गई.
लाइव स्ट्रीम पे चेक करो, हमारी आवाज़ क्यों नहीं आ रही है?
युक्ति लाइव स्ट्रीम खोल के उधर जाओ और जो हमारी आवाज़ सुन लो. इधर करो पहले. लैपटॉप इससे तो कनेक्ट करो.
जॉइन मीटिंग को।
किसी भी टाइम पे
हो गया? कौन से इंटरनेट से चालू हुई है? मेरा इंटरनेट एक जगह जाएगा, 2-3 जगह वो नहीं दे सकता, ताकत एक ही है उसमें। आवाज़ नहीं आ रही ना हमारी, आवाज़ नहीं आ रही जी शॉट, वरना सारी बकवास।
इनकम भी कौन से कुछ नहीं.
Hi ma'am, are you audible? Yeah, yes, you are audible. Just a sec, ma'am. Start in a while.
Yes.
Good evening.
Good evening.
Hi. Good evening, ma'am.
Everyone.
Am I audible?
Yes, you are audible, Lakshmi.
Yes, you're audible. So when you're audible. It's just a small technical glitch, ma'am. We'll be starting in 2 minutes.
Hello.
Very sorry.
Am I audible?
Yes, you're audible.
Archimedes once said, mathematics reveals its secrets only to those who approach it with pure love for its own beauty.
A very good evening to everyone present here. All of us have been looking forward to this day since we got to know this was happening. We're absolutely privileged to have with us today Dr. Neena Gupta, who doesn't really need an introduction. She was awarded the Ramanujan Prize in 2021, becoming the 4th Indian and the 3rd woman to receive the prestigious award. She was awarded the Shanti Swarup Bhatnagar Prize for Science and Technology, the Indian National Science Academy Young Scientist Award, Associateship of the Indian Academy of Sciences, the Nari Shakti Puraskar for this year, and numerous other laurels as well. Well, if we keep listing out her accolades, we'd be here all day. So without further ado, and with immense pleasure, we at PI, the Mathematics Department of Hansraj College, welcome you, ma'am, to the first day of Sri Shanti Narayan Conclave 2022. We hope you have been having a nice day
Yes,
today,
yes,
ma'am.
of course. So how are things going on there?
Yeah, it is a great pleasure to host you. So yeah, we're extremely happy today. So shall we start?
Yes.
Okay.
We would like to embark upon the conversation with you telling us something about your journey, like from not wanting to continue pursuing mathematics in graduation and all the way to winning one of the most prestigious awards, the Ramanujan Prize.
So, okay, so let me first correct, Miss. I don't know. This information is probably not correct that I didn't want to continue with mathematics during my graduation. In fact, throughout my life, from my childhood, I had huge passion for mathematics. So maths was my life. When in high school, when most of my friends were going for engineering and medical, I met one senior and she suggested me that she is doing maths honors. So I immediately just realized that I have to do mathematics and will be studying mathematics throughout my life. So that was, but okay. So what was not clear to me at that time of graduation was there is a career in mathematics and there is a life beyond research, means beyond your graduation, that there is a life of researcher in mathematics, which I can pursue. So that was not very clear. The path was not clear, but that I will be with mathematics, that was always something like a dream coming true.
Okay, so we have been misinformed. We read quite a few
No,
cases.
no. So what was not clear is that I will be going for research or I will be going for
Yeah.
PhD. But mathematics was always there.
Yeah.
That I love doing mathematics.
Okay, that is great to hear, ma'am. So seeing seeing how you've been in, you've been admiring maths since
Yeah.
forever, and you were initially, I don't know if this is correct or not, but you were discouraged from pursuing the Zariski's cancellation
Yes.
problem, right?
Yes.
In the beginning. So like now how everything's turned out, how do you deal with such situations? What motivated you to
So
continue with
actually all it happened is that I was studying independently many things right from my PhD days, but it was a coincidence that when I was studying all all these things, the Professor Asanuma was visiting ISI Kolkata. So he's a researcher he's a big professor in the field of mathematics. So as such, when a professor from Japan is coming, the students usually try to much information as we can from the teacher. Like, means you people are also students. So if you know that some expert is coming, then you will try to read up some things and ask questions suitably. So I was reading up his papers. There he found one of his example, and I had some ideas. I asked Professor Asanuma that, sir, we can do this, we can solve this, but he was very kind enough. He said, Neena, this is very difficult, you don't try it. And he said it in a very good way. Means he was probably trying to save me, because I was a researcher, PhD scholar, and I have to submit thesis, so I should be more inclined in towards submitting thesis and getting a postdoc somewhere, rather than occupied with one particular problem which he thought was very difficult. So in a way he was correct. So the problem had two parts, so I could solve it for only m greater than equal to 2. So the m equal to 1 part is still an open problem. And after submitting, so I got busy with other things, like other papers which I had to complete, and then research and getting PhD, applying for postdocs. And so when in TIFR, when I was have some free time, I started thinking about that and solved it. So looking back, it seems that everything came at the right time. When I was well prepared to handle that problem, I took it up and could do it. Yes.
Okay, so and you actually did finish your PhD in time, before time actually, in contrary to that. So that was actually very uplifting for everyone here.
Madam, it is a commonly held belief that academia is a male-dominated space. Would you agree to it, or does it, in your opinion, makes academia a less inclusive place for women?
It is not. See, in fact, yes, there are very few women in mathematics or say in academics, but there is nothing like that we prevent them from coming. So it is up to you. It is your interest whether you can take it up. So what is true is that we are all blessed equally. So there is no bias when God has created us, and we can do many things. Maybe we are not very physically strong as they compared to them, but we can be physically strong. So as you can see, women are there in every field, right from the farms to the pilot. So she is there everywhere. So she can do, and she can also do academics. There's no doubt about that. Yeah. So, and it's not that anybody is preventing you from coming here and grabbing the position. So you are very welcome to do this. So
Yes, ma'am, exactly, very true. No one is preventing them. They are that much capable to do it, but still there is a minority of women there, like
yeah, so
or postgraduate. Yes, ma'am.
So there may be some kind of hurdles which we see. So there is a sharp decline after graduation and post-graduation for research or STEM career. So maybe they are more inclined in, or there is a family pressure or societal pressure for going for more lucrative jobs and or for settling up in the life. So as you all know that it takes a long time to get settled in a research career. So for instance, if you start a research in mathematics or PhD, then you spend a lot of times, like so at least 5 years or years in postdoc, so including 9 years after your post graduation. So that may be too much for a woman, but yes. So in my case, what I feel was a strong point was that I had a very supportive family, and they had a huge belief in me. So my father always supported me. When I told him that I want to do PhD, and he immediately asked me how many years. So after MSc, MMath, which I completed, the next question was how many years. So I just said that it gives us 5 years of time, but there are some professors in ISI who have completed in 3 years. And he immediately said, you will finish it up in 2 years. So that was his encouragement. Thankfully, means it's because of his blessings that I could complete the actual thesis work. the research part of it. It actually took within 2 years. And of course, it takes some time in writing up and getting it accepted and so many things. So it was 3.5 years overall. So that is the point I am trying to say, that it's not always that the case that people finish it up so early, and it takes a lot of time to getting started and research. So that is why probably there are very few women, because it takes a lot of time to get started.
Yes, ma'am. Your answer does provide a more nuanced insight to the situation that what we were discussing about. So, like right now, we look up to you and idolize you a lot, especially as a woman in STEM. So, do you see a mathematician or academic as your idol like that? If yes, would you elaborate on?
Okay, so one ideal which is probably not just for me, it is an ideal of many of the mathematicians, not even women. Means in fact, even a male can have him as an ideal. So she is Emmy Noether. So Emmy Noether is one of this Polish mathematician, and she was great. So throughout his life, she has proved several mind-blowing or many fundamental results in algebra, and she gave birth to this area of commutative algebra in which I am working with. So she is also known as the mother of commutative algebra. With my professor Amartya Kumar Datta, I have written an article on him. So it's so Emmy Noether is an ideal which I would really admire as a mathematician.
All right, ma'am. That sounds inspiring. She sounds like an inspiring woman. I think we'll look up more on the person, because as so as we've seen,
There is probably some network issue.
Am I audible?
Yes, you're.
There was a little, yes, there was a little disturbance. Sorry, ma'am. We would like to move on to the next question. As you have seen your work on affine geometry, and a student usually learns Euclidean and Cartesian geometry in schools, but after that, at many universities, including DU, a geometry course is introduced in masters only. So, do you think geometry should be made a part of the UG curriculum itself? And if yes, then what type of geometry may be a good component of this our UG course in mathematics?
So the geometry which you're talking about, this algebraic geometry or topological geometry, it is very much there in the courses, but it is probably not spelled out in that way. Like in coordinate geometry, which we do, you yourself have said about the coordinate geometry and so on. So, but I feel that it probably cannot be introduced earlier because it requires a huge background. So the machinery itself takes a lot of time. Now, Miss, the earlier, see, what we can do in high school or in undergraduation is that we can read that type of geometry which was done before 19th century or say 19th century. But in 20th century, it had taken a huge change. And because of that, it has become very formal. So earlier, things were done informally without things defined. So now things have become very formal, and so now to understand that you need a lot of machinery and a lot of things you should know before going into that subject. So introducing it in full-fledged thing is not possible. However, we can introduce some basic courses like an introduction to the elliptic curve, introduction to curves or something. But even that, I would say it will require a bit of background for the student to come.
yes,
Yes, ma'am.
that's a very valid reason for how things are like how they are right now. So you were saying we could introduce some basic concepts. We could try to introduce some basic concept like curves to the curriculum. So on that, what are your thoughts on the scope of pure mathematics, specifically concepts that necessarily don't find applications in other fields?
Okay, so the concepts which don't find in other fields, so it's being a pure mathematician, means I work in pure mathematics. So telling that how it feels. So this is what I asked my guide one day. So he said that pure mathematics people should keep on doing independently, and it's not that many people are taking up. It's very only a fraction of almost a negligible amount of people who are in pure mathematics, and that should always be there just for the sake of its mathematics. Just for the sake of mathematics, it should be there. It's not that they all of them, everything of them will get not seen or will not be applied. It may not be in the near future, but in long term, everything is going to be used. So like if you see the just one simple example I am telling you about Ramanujan. He used to work with these continuous fractions and power series expansions and many formulas, and so those were all pure mathematics. But now, even in the studies of black hole, there is a Ramanujan's tau functions which is being used in the study of black holes. So it is after 100 years, his theory is being applied. So what is I'm saying is that what it seems to be pure now may not be pure after 100 year or 200 year. So there is an application, and just for that sake of application, it may take a long time. So pure mathematics is what? A curiosity which comes to you, a question which you would like to find an answer to that. So those questions should be taken up, irrespective of whether it is going to be used now, or will it be of any use to the mankind now, or is it what good it is providing to the society. It should just be taken up for its own sake, and in future there will be some applications, hoping that, and it will have. It is not seeing that application, some other generation will be able to see that.
Yes. So, like you said, what might seem as pure mathematics now can find applications in the future, right?
Yes.
So, but still, there is a, as you've mentioned, there is a lesser fraction of people going into pure mathematics. So, what do you think can be done in terms of undergraduate students, or to encourage undergraduate research? Because I'm not sure if you noticed, but the entire department of mathematics is seeing this event. It's being streamed. I'm sure many of them.
So your question is whether how to encourage people taking up pure mathematics or undergraduate mathematics. So let me just be very frank, it is not for faint-hearted people. And things are always not the same. It has very other side of the coin. It is not so bright, and it requires a lot of dedication, passion, and a lot of sacrifice. So it's not that you're studying and it will give you results. So it involves a lot of patience also. And with sheer brilliance and attitude is always sustainable with it. Means to be sustainable with a problem. So I will personally not encourage people to take up research or pure mathematics. On the other hand, I would say that if you people think you are good, or if you think that you can remain with a subject forever, or you love it, you have a passion for it, you have a dedication for it, then only you come here. And it will be always rewarding. So if you think you are good at it, or you would like to find questions to your answers, or you have some curiosity to know the nature, or you have curiosity to do something for the country. Also, research is something which we are doing for the country. So if you think that you have the capability and you can do it, then please do come. Our country needs it. Our country needs research. Our country needs pure high standard of research, and for that we need good minds. Most of the good minds either goes away in IT companies or abroad, but we need good minds. And but come here with a feeling that yes, you're doing it for the country and it is for your duty, you are doing it. And it's not always the same. Means it takes a long time for anyone to get here settled and to do research. And on some problems which we are working with, it doesn't get solved immediately, or it takes around a year or 2 years. So you have to stick with it. Means it's not that maybe when you're not able to solve that problem, there is some basis fundamental thing which you need to first prove, which you're unable to see. So that will take time. It's not it's not always very easy to get results. So if you are here, please do come. And it's again, it's not. And see, I can give you my example. I used to, I love mathematics a lot. If you allow me to study, I can study from 8 o'clock to till 12 o'clock, 1 o'clock in the night. I don't matter what time it takes. And I can remain with it. Even without food and water, it's okay. But, and there are many people, researchers have to be of that sort. It's not that, I don't know whether I had any weekend. Even now, if I have a weekend, it may be once or twice in a month, but I never have weekends. So it's always with my books. So this is what, and for most of the researcher in lab, physics or chemistry or biology. So, but they have to enjoy. It's not that I'm not enjoying. I'm enjoying my part. I'm enjoying my books. I'm enjoying my problems. I'm enjoying solving that. So if you get pleasure in doing so, then please do come.
Well, ma'am, as you have mentioned, that's really true that we enjoy mathematics. That's why we are here. But as you said that you used to spend most of your time on doing mathematics, like you love doing it. But has there been any other activity or activities that fascinated you, or that you like to do in your free time, except all about this academia and all?
No.
Like,
so earlier, before coming into IS, when I was in school student or something, I used to love drawing, or say learn listening to music, good musics. So those things I used to love, or I used to go to places. But after coming to ISI, the only thing which I love is reading papers and doing research.
Yes, yes, and we can see how much you enjoy it. So that was really great to know. Now, coming back to academics, specifically the statistic cancellation problem, which quite made the landmark through the globe because it was unsolved for such a long time. And you have mentioned it is very difficult to understand, or for a layman to understand. But can you briefly explain or try to make the UG students understand what the problem is?
So, okay. So I can explain a little bit of it. Say it's about the cancellation. So which is a theme which is very important. For example, if I say AX is equal to AY, then you can clearly cancel A from both sides and then say X is equal to Y. So this is what we are doing. We are cancelling. A times X is equal to A times Y, then X is equal to Y. But this is not always true if you put A equal to 0, because 0 into 2 is equal to 0 into 3. So you cannot cancel. So point is that when we can do cancel, what can we do? So that is an important question. So this is a very fundamental thing I told you about school days. But in higher mathematics, I don't know whether you have seen vector spaces. So vector spaces are clearly determined by their dimension. So if you have a vector space, you add one more dimension to it, and suppose it is isomorphic to another vector space plus one more dimension, then you know the original vector spaces were isomorphic, because vector spaces are determined by their dimension. So you can clearly cancel vector spaces. So Zariski's cancellation problem was about cancellation of affine spaces. So it is affine varieties. So it is just not a vector space, it is a vector space along with a topology. Briefly, in a very raw way of saying is that, suppose you have a curve, you were just talking about geometry, so you know about curves. So suppose you have two different curves and you look at the cylinder over them. So over a curve, it will be like a surface. So if these two surfaces are isomorphic, can you say the original curves were also isomorphic? Known to have an affirmative answer for spaces of dimension less than equal to 2. And what I have shown is that for spaces of dimension in positive characteristic greater than equal to 3, they all have counterexamples. So you cannot cancel in positive characteristic. So that is what is the cancellation.
Thank you so much, ma'am, for the explanation. We all know that we are not that much mathematically mature enough at this stage
But
to
still, you are a
understand.
mathematics student, so
Yes.
I suppose it will be.
Somehow we have understood a little about vector spaces and all, but that the way that you explained it has sparked the interest of everyone here, and they will surely look into it more. Now, ma'am, as mathematics has been a very important part of your and everyone's life over here, and it lays the foundation for almost everything in the world. So, what do you think about mathematics? It is discovered or invented? For like, for example, if we ever encounter an extraterrestrial civilization, do you think the math, their math and our math will differ by symbols only, or will there be a different sense of their sense of subject will be a whole different
I
thing?
think whatever it will be probably around the same line, but there may be a gap of this gap. Maybe, see, I give you some very simple example. Earlier in ancient mathematics have developed a lot. So around 6th and 7th century, during the time of Aryabhatta, Brahma, Gupta, Bhaskara, and mathematics have developed a lot. Arabics have picked up algebra, like zero and the decimal system. It went to Europe from here. So, and so around 6th and 7th century, our mathematics were probably at the peak. And at that time, the kind of questions or kind of work we have done in mathematics or in algebra. So algebra was defined at that time. Or so algebra of polynomials, or and working with polynomials like continued fractions, solutions of this Pell's equation. So if you just search by Pell's equation, you will find out that it was a problem which was posed by Fermat in 17th century. But those problems were discussed and solved in India even in 6th century. So I am saying that it took around 1,000 years for Europe to reach at that level. Unfortunately, they were quite fast. Means they didn't stop there and they progressed high. On the other hand, in India, there was a decline of civilization, and we could not really make up with the Renaissance and the development. So what I feel is that even if it's in some extra celestial space, if they are coming up, they may be either ahead of us or maybe behind us, but it will be actually taking us the same path. So all you need to know is that it will go along the same path, which I feel, as it happened in other parts of the countries. So now it's very connected. Earlier it was not that connected, right?
Yes. Such discussions are always very interesting and very fruitful. And it was quite interesting to know it from your point of view. So as we are discussing about mathematics and how it evolved, how were you taught during your student years? Like you've mentioned how much your father impacted in your the journey of mathematics. Like, did your other mentors have an impact on you? And you also teach right now, right? So has this influenced?
So yeah, there's some network issue. Am I audible?
Yes, ma'am, you're audible. I will repeat the question for you. The question is how you were taught during your student years. Like, as you mentioned that your father had a very positive impact on you. Like, did your other mentors had an impact on you? And you also teach now. So, is there a impact it has created on you on how you teach
So
now?
actually, it was my mother, Miss, who taught me right from the beginning to the school days. In fact, she taught me class 9, 10 itself. So she was my first teacher. In school also, we got very good set of teachers, and so is in my college. They were very encouraging. And fortunately, I landed up here in ISI. I got selected for the master's program, and the teachers of here were really very wonderful. They just introduced me to the whole world of mathematics. This place is quite different from any university or school. They are very encouraging. And I remember when I was struggling from the transition period from university to ISI MMath program, I was really struggling. At that time, I was behind many of the curriculums. So the teachers were very encouraging. If they could see my face and say, "Oh, Neena, you don't know this," then I would ask, "Sir, I don't know this." Then on the other side of the board, we will just go and write up some definitions and ask me, "So this is a definition, and you can read it up from so and so book." I used to go to library and read it from there, but they were never discouraging. They never said that you cannot do it. So thankfully, I got very good set of teachers, and I try to maintain that. I've been teaching for last 10 years, so I'm trying to maintain that in my students, to my students, and I get very beautiful emails from them who have got positions abroad, or say postdocs abroad or PhD and abroad. They write to me thanking me for my teaching. So I really feel that this is what is my duty towards ISI or their teachers, so who have trained me in such a way that I just follow their footsteps.
Yes, ma'am. You are indeed leaving behind a very beautiful legacy, and we all are proud of that. So we are almost at the end of our time. So as we are about to conclude, what would you say to the budding mathematicians about math and life in general?
Maths is a very beautiful subject. It's one of the most beautiful subject, and those who do it, they know that it is not comparable with any other subject. Even in physics, I used to enjoy a lot, but there's certainly a big difference between what mathematics is and what physics is. So it's a very beautiful subject, and keep doing it. There is a high chance of having success in research, success and having a life in mathematics, or say career in mathematics. And there will be dry phases, so be with it. But if you enjoy, and you will not find it lonely. So this is what a message from me, that there is a career in mathematics you should pursue, but don't pursue it with the aim of earning money or mining money. Thankfully, our government provides some good fellowships, which is sufficient, or at least for your own living, or taking care of your living expenses. But don't have any high expectations. It's not possible for any country or miss to give huge miss who were not having food to eat, or neither miss he was not even having papers to write. So he used to solve problems in some cargo materials which is used for shipping and packing material, and only he could write had one diary could write the theorems. So his diary is full of theorems without any proof. Thankfully, miss, we are not in that stage, miss. Our government is providing that much of fellowship for our living. So we are thankful to that, and that is what at most we can expect. Maybe in future, when we become more strong, our country becomes more strong, we will have some good fellowships. But there is a career in mathematics, and you people should try to pursue. You are the miss. What I can say, they are the future of our country. So people should be encouraged to do research, and for the sake of our country. Yes.
Well, ma'am, your words were really inspiring, and hope everyone will get to know what it is really is, and they will learn to see the way you see mathematics. With that, I think we can wrap up the interview session now.
Thank you.
Neena, ma'am, we would We are sure all your deep insights and beautiful pieces of advice will be helpful to all of us, especially to the emerging mathematicians looking to follow in your footsteps. We express our heartfelt gratitude again to you, ma'am, on behalf of the Department of Mathematics PI of Hansraj College. Thank you so much, madam.
Thank you
Thank
for
you
the
so
kind
much.
invitation. Thank you.
Thank you so much.
Mukund sir is also here in the meeting. Sir, he was the person who had a very key role behind making this happen. He assisted us so much with everything. We are so grateful for you, sir. And also to everyone who joined us today, thank you so much for being here. We hope you enjoyed the interview and the insights ma'am provided. That'll be it for today. Thank you.
Thank you, everyone. The meeting is ended. You all can leave now. Thank you. Thank